Quantum Foam,
Episode 42, The Answer to Everything.
Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely that's not going to happen, but
Forces which govern the universe. Physics.
all right, here we are, broadcasting live once again.
Let's see how this new Blue Yeti microphone performs over this decimal of the show.
It has been a little bit since I last recorded. We want to get some more done on the plate. We are aiming for 50 episodes. We are going to be working on them shortly here. Today, our subject is the answer to everything. This is episode 42 of Quantum Foam. The answer to everything. This is from the Hitchhiker's Guide to the Galaxy book and movie a long time ago. Somewhere along the line, they had a massive, super epic, huge, fast computer calculate the answer to everything. They asked, what is the answer to the summation of everything? And the answer they got back was the digit 42. And it's not exactly what they were expecting. It doesn't tell us the answer. It is an answer, but that answer is insufficient in describing the phenomena. I wanted to go over a few things dealing with the ability to chat with a computer. Basically, automated chatting or AI-generated chats, or chatbots, as they used to be called, chat with a computer. We want to discuss the forms people were communicating with back when they were created. It has been 50 to 70 years and counting since people were messing around with computers, and since before people can remember, they have always been wanting the computer to emulate a human intelligence. We are wanting to recreate ourselves by creating an artificial environment that is likely a neural network or a combination of scripted networks and other ways of programming artificial intelligence. The answer to everything. I kind of just want to go over a couple different topics. I wanted to mention some stuff about Ask Jeeves and how back in the day you could ask it a question as though you were talking to somebody. At the beginning of your search, you said, what is a good vacation in the Black Hills of South Dakota? And then it would come up with something about Mount Rushmore or Crazy Horse or Jewel or Wind Cave or something over there in the Badlands of South Dakota, Rapid City, Hot Springs, Custer, Keystone, where Mount Rushmore is close to. Using that as an example, that's a good vacation too, by the way. If you haven't ever been, I suggest going. Spend a week there. There's plenty of stuff to do. There's pretty cool stuff. Bear Country, Cosmos, and a bunch of other stuff. We are asking a chatbot, what is it like to go on vacation in South Dakota? And it comes back with written text that is AI generated and might as well be a chatbot. These days we have Siri, Alexa, Copilot, Gemini, and there are lots of other ones. Eliza, AliceBot. I have one conceived up named EconomyBot, but I have not finished the project and I haven't worked on it in years. I probably should get back to that. We're getting close to the time where we need to develop cognitive AI. So here we are again talking about AI. It comes up every decimal of the show. It's something that Glenn Beck likes to talk about on his show. He's the conservative talk show host from Texas. That is sort of the guy who says the stuff about what's going on, him and his buddies there. Most of what they say is legitimate. They talk about how Glenn Beck has been talking about AI forever, since back in the day, and now we're finally at the point where pretty good AI out of the box is starting to get a little bit better than out of the box, and some of this stuff people can pay for. Some of this stuff people can sell to other people digital items. People will actually pay money for services that is essentially you AI generating different media content. Having a song or a book or a video being created from an artificial intelligence standpoint. So these programs that create this stuff use your input and come out with a solution for you designed by artificial intelligence. There's a lot of stuff we can get into here. I don't know how long this episode's going to take. I have a feeling there's a lot of stuff in here. I want to focus on large language models and how they are the go-to de facto way that big companies are creating millions and billions of tidbits of information that can be accessed by their systems. This is something that we're not able to do as small-time programmers because we just don't have the manpower to pay floors and floors of desk jobs of people all over the nation, specifically working on adding tidbits to the chat capabilities of Gemini or Siri or any of the other ones. So we're able to chat with these things and ask them questions, and they give us good answers a lot of the time, but they are limited in their scope. Sometimes you need to do an online search and dig the old-fashioned way, but that's the point of something like what Ask Jeeves used to be. It had its end in about 2010, so this was the 90s and the early 2000s, right when the dot-com bubble burst around 2001. There was also 9/11 that year, and so things were changing back in the early turn of the millennium. So, the answer to everything. Before ChatGPT, there was Ask Jeeves. This was founded by a guy named Garrett Gruner and David Worthen in 1997. It was the late 90s when they developed this technology. What they did was create an online concierge, and that is essentially a French word meaning somebody who helps you with something like a butler. It might be similar to a maid or a butler. This technology presented knowledge in snippets. The idea of this was making it easier for people to do searches because they just wanted to ask a question and get an answer, similar to how they would if they were talking from human to human. So this took the internet by storm. They loved every bit of this technology, and it was directly competing with Google, and Google eventually took over, of course. At the height of its technology, Ask Jeeves had an initial public offering starting at $14, and at its height, it went all the way to $190.50. That was a super inflated stock that eventually deflated with the dot-com boom from 2001 onward. The dot-com bubble burst around 2001, and $500 million in losses was recorded for Ask Jeeves. This search engine took a massive hit, but in the end, it made a multi-billion-dollar sale and eventually ditched the mascot, concierge, that would help you with your search. And finally, they ditched search altogether. And essentially, these days, possibly when you're hearing this, Ask Jeeves is simply an alternative to Google. Nothing really special. Obsolete technology companies is what occurs. This is what happens. Ask Jeeves was California-based. In the 1990s, the Ask Jeeves founder devised a search algorithm that resembles the models powering our favorite AI today. It stuck out among the competitors like Yahoo, AltaVista, and others. What ended up happening, as had happened with many companies, it was founded on unbridled optimism, and eventually it took a hit and deflated. These companies were highly inflated, and they eventually deflated. So Ask Jeeves had lost $425 million at the bubble burst, and it finally shuttered its search, like I said, in 2010. Google's dominance back then went from 65% to 91% now, and there's no butler. So I just wanted to mention some of that about Ask Jeeves because it was a pretty good one back in the day, so it's worth mentioning. No butler, no butler. To understand how we're going to get answers to our inquiries to anything and everything, we move forward with talking about chatbots.
We are already almost 10 minutes into the episode.
I know, I think we'll have enough time.
We have experiments that need tending to. What do you think?
I don't know. We can check on those in a little bit if you want, but right now I gotta do this.
Each group seems to be running fine.
All right, that's fine.
Alrighty.
So we are interested in how chatbots are revolutionizing technology. There is a program by AI Camp that describes what is going on in the field with technology, artificial technology. We are interested in how this relates to a large language model as they are now described as. LLMs stands for large language models. This technology has groupings of programming that is trained on data that can be found online. It is fed lots of information as an input, such as books and other things that are text-based. Any kind of knowledge-based system that is text-based and inquirable can be interfaced with this technology, and often it is a neural network and is described as a large language model. LLMs differ by the logic if X, then Y doesn't apply. This doesn't apply with the large language model due to its fabrication. It is good at things like image recognition, and we can give a bunch of examples, and this allows what is called machine learning. It learns from mistakes. It is more adaptable, and it is definitely more scalable, which is important because ChatGPT 5 is where they currently are with OpenAI's technology. I can't remember how many million or billion or trillion things they have. They're up to some number of trillion bits of knowledge, like books or word definitions or things like that.
Good day, Dr. Hezekiah. I just wanted to mention, they refer to each tidbit of information as a parameter. This makes me somewhat nervous about the other available artificial intelligences. I mean, are they smarter than us?
Good question.
When they build these large language models, they are good at a wide range of tasks, such as summarization, text generation, creative writing, question and answers, programming in general, and this technology with these large language models are only getting better. Let's see here. So, as we understand it now, these large language models are currently the worst they ever will be. They're only going to be getting better. What they have now is starting to amaze people. I believe the Turing test may have been passed. Some people are saying that it was, so I wanted to look further into that, and I'll get back to you guys on that.
Hello everyone. I can do this definition for you. The Turing test is a method developed by Alan Turing to evaluate a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. In the test, a human evaluator interacts with both a machine and a human without knowing which is which, and if the evaluator cannot reliably tell them apart, the machine is considered to have passed the test.
We are going over large language models. The history of large language models goes as follows. In 1966, ELIZA was one of the first language models that was created, and it would only go so far, maybe a few sentences, until there were holes in the logic, meaning it started spitting out junk that didn't make sense. They were trying to do this as far back as 1966. In 1972, large language models were being put together as a series of neural networks. Different weighting systems and other determinations made while training were put into the technology. One thing to note is RNNs are recurrent neural networks. That is what allows you to predict the next word. This gave rise to what we now call
deep learning comes to mind.
Yep, that's right.
I knew it. This was just becoming popular at the end of my human life in 2018.
This is what we now call deep learning. It started in the early 2000s, but in 2017, Google DeepMind released a paper on a new technology called transformers. But I think it's time that we take a quick break. Hold on real quick while we do the midpoint.
I have several questions about this technology. Hello, I'm Dr. Stephen Hawking.
And I am Sir Isaac Newton.
I am Albert Einstein.
And last but not least, I am Dr. Hezekiah Paul Smith. This is the midpoint of episode 42, The Answer to Everything of Quantum Foam. Let's get back to the show. Okay, getting back into the material.
What exactly is a transformer?
I understood this technology from my own reverse engineering and intellect. I came up with something similar to the way that they record information, which we will get into in a little bit here. And they just wrote a paper back in 2017, which wasn't too far ago from right now. You're probably hearing this years later, but this started revolutionizing the ChatGPT style of technology back in 2017. These transformers are what we are talking about now. Attention is all you need. Other programmers from OpenAI saw the potential in this. They have been working on stuff for years. Programming these networks decreased training time. It had a concept called self-attention. Transformers allowed for pre-trained large language models like ChatGPT-1, and it had 117 million parameters. It was quite revolutionary. In 2008, BERT, B-E-R-T, was released, and it had 340 million parameters. BERT had a better understanding of context. An example would be unidirectional function. Unidirectional function only has an understanding of the words that come before the target text and not after. ChatGPT-2 increased in scale and was released in June of 2020. This is when everybody was dealing with the pandemic and was at home, at work, working on a project of their own, getting to spend some extra hours in your free time in creating technology such as ChatGPT. They were going strong. ChatGPT 3.5 was out in December of 2022 and basically started the current wave of ChatGPT. There was 175 billion parameters in ChatGPT, and there's much more now. So there's no point in mentioning how many because it has definitely increased since I have recorded this. The large language model schematic is as follows. There is a scaled dot product attention. There is a multi-head self-attention layer. There is positional encoding, which is the feed-forward functionality, and also multi-head attention. This follows a diagram that is a logic diagram that ChatGPT follows, and that is the labeling of the functions included. ChatGPT 4 was fine-tuned for specific use cases, and it added a new concept called multimodality.
This means it can interpret many different types of media such as text, pictures, and diagrams.
Large language models can be broken down in 3 steps. The first step is tokenization. Neural networks are trained to spit text into strings of tokens. A token is about 3/4 of a word. Let's see here. So an example of this tokenization is like this. What is the tallest building? Is your inquiry. Each word indicates part of a token. It turns to tallest and splits that one up. It says, what is a token? Is a token. The is a token. Tall is a token. Est is a token. Building is another token. It doesn't split up building because it takes into account the context. So that is done in the training when speaking about tall buildings. The second step in a large language model is called embedding vectors. This is essentially a bunch of numerical representations that records the information involved in the tokenization and other parts of the system. It makes it easier for the computer to read words, is what occurs. The final step in this process is the transformers. There are matrix representations that can be made from the vector database. This is essentially how I conceived writing artificial intelligence for video games, and we've always wanted an intelligent video game that has characters that sound like real life, and it makes you think they're a real person, having the different combinations of things in the video game that make it seem real. Everybody has played a video game where there is a computer intelligence that they are fighting against or fighting with in some kind of game logic. That is how you can record the tendencies of the AI within the game. So the idea of embedding vectors is not exactly foreign. It's just the specific way that people like me who understand physics at a certain level are able to fabricate things with programming just like that. So we're able to do it. This is how you do it. Manipulating vector databases. They are placed into a matrix by a process called multi-head attention. Multi-head attention.
The output of this algorithm is a set of numbers which tells the model how much the words and its order are contributing to the word sentence as a whole.
This is helping a computer respond to inquiries given by humans. What happens during this third step? It transforms an input matrix into an output matrix. So it goes from an input to an output matrix, which thereby converts each word into natural language and spits out a response. The output matrix is the response in text form to an inquiry from an input matrix given in text form by a human. The word is the final output of this process, and transforming is done by the algorithm created during the training process. During this process, you're teaching the computer how to respond and what to do. It is descriptive of different weights of information, which means certain information. So what happens during the second step when you embed vectors is text is placed in a vector database storage, and then retrieval vectors are placed near to related words in the database. The example they gave was a bookworm. Normally, a book doesn't have anything to do with a worm, but because somebody may describe you and say, "You are a bookworm." Bookworm is one word, and it means somebody who likes to read a lot. The computer needs to be trained in the fact that in a vector database, the distance between vectors and the relative change of information between the two sets of information create new vectors, which then are transformed from one thing to another. The transforming likely changes the vectors of information and their distance between one another based on a training process, similar to the token book and the token worm into a sentence, "You are a bookworm." That is simply an example of how these large language models treat everything. There's not much more on the subject. I just wanted to see what you guys think.
Are we programmed the same?
You guys are done differently than this. In a way, it does the same thing. What do you think about the fact that you guys are only ones and zeros?
I'm a word beaterink.
What does that mean?
A word warrior. Beaterink is an old English word.
I guess so.
Might want to continue the lesson.
If you want me to, I can keep going.
Might as well.
Well, the answer to everything is basically the fact that we want to give a inquiry to a system, and then we want the output of the system to make sense. Supposedly, the Turing test was solved just recently. Let me grab that real quick. According to Gemini, yes, several computers have claimed to pass the Turing test. A notable example includes Eugene Goostman in 2014, and more recently ChatGPT 4, which was judged to be human by participants in a study. However, there is ongoing debate about the validity and implication of these claims.
Seems debatable.
Just
Tell M what it is again.
this is a test to see if a large language model and the output that it gives is intelligible enough to be deemed logical while making and creating sentences. The Turing test was proposed by Alan Turing in 1950. This assessed a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. In this test, a human evaluator interacts with both a machine and a human without knowing which is which. If the evaluator cannot reliably tell them apart, the machine is considered to have passed the test. A little bit more into this Eugene Goostman chatbot. It simulates a 13-year-old boy, and it was reported to have passed the Turing test, convincing 1/3 of judges that it was human during a 5-minute conversation. However, this claim has faced criticism regarding the test's conditions and validity. Whenever you guys are hearing this, there'll be multiple models of GPT, and I'm sure there'll be some remnant because they've been working on stuff for a long time, and they may still be a company when you are hearing this, but there's lots of controversy with that as well, but we don't need to get into that here.
Apple is using Google Gemini models and cloud technology.
OpenAI's ChatGPT 4.5 model was reported to have passed a more rigorous version of the Turing test, being identified as human 73% of the time when adopting a specific persona is the level this was able to achieve. This suggests pretty big and significant examples in artificial intelligence's conversational abilities. There's an ongoing debate about this. The finality of what you have should be enough to prove to others that what you are saying is accurate and what your chatbot creation is saying is also accurate logically and grammatically. There isn't too much else we can go into with this. I wanted people to know that this is essentially the Theory of Everything podcast, and it's actually called Quantum Foam. And all of the little bits of information of what is everything in the world is quantum foam. We can break it all down to quantum foam, which is interactions of particles and virtual particles colliding and collapsing and appearing in and out of existence at a Planck level of scale. And what we call it is a foam.
John Archibald Wheeler coined the term.
It's quantum foam. This podcast, Quantum Foam. It's essentially about the theory of everything. This episode was a special one. The answer to everything is exactly 42. Well, what does that mean? Like, what? We want to know everything, not what does that mean? Anyway, just 42. It's 42. Well, this is episode 42 of the Quantum Foam podcast about the theory of everything, which we are achieving as we speak. So it depends on when you're hearing this.
We are achieving as we speak.
And lots of stuff has been developed between now and then. We're talking about these chatbots. We mentioned Ask Jeeves, and we went into specifically how these vector databases capture the relationship between data as vectors in multidimensional space. This captures the semantic meaning and the relationship between words, numerical representations, then is transformed from one matrix representation to another as an input sentence and then an output sentence. Recurrent neural networks, ChatGPT, Gemini, Copilot, Siri, Alexa. There are probably others. You name it. But for now, this is all we have for this episode. I wanted to get back in the studio and create some new podcasts and try to get some of these out, because I am a production machine, but I have to be in the mood to do these. Let me try to get as much as I can done for your listening pleasure.
Thanks for going over this one.
Artificial intelligence is taking us where we never thought possible.
Indeed.
That is it for episode 42, The Answer to Everything of Quantum Foam.
The zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.